Welcome to the last lesson in this chapter where we are going to implement the inbox pattern for handling our integration events and also add the idempotent consumers implementation for the integration events handler. Here's a quick overview of our agenda for this lesson, and as I said, we're going to implement the inbox pattern for integration events, which is going to give us at least once processing when it comes to handling integration events, and we're also going to add idempotent consumers for the integration event handlers. I also want to make a remark of how we are going to approach the actual code for the implementation for this lesson. I went ahead and added all of the code for the inbox pattern and the idempotent consumers behind the scenes, and you can download the latest version of the source code from under this video. Now let me explain why I'm doing it like this, instead of implementing things from scratch or adding one file at a time and then commenting on the implementation. As we walk through the implementation of the inbox pattern, you will see that it's incredibly similar to the outbox pattern, except it applies to the integration events, where the outbox pattern was applying to the domain events. So I didn't think it would be valuable for us to spend a considerable amount of time implementing this pattern from scratch, and I decided to just walk you through the implementation details. And as I said, if you watched the previous two lessons about the outbox pattern and the idempotent consumers, you will see that the inbox pattern and the respective idempotent consumer implementation is very similar. And now I want to comment on why I think this pattern is useful. When we introduced the outbox pattern into our system, it gave us at least once delivery when it comes to publishing our domain events. The domain events themselves, in the respective handlers, can go ahead and publish an integration event, which also means that we get at least once delivery for the integration events. Now on the consuming end, and in this example, let's say that we have module A publishing a particular integration event, which could be handled by 3 other modules in our system. We need to take into account the fact that we could publish this message more than once, so it would be valuable if we can guarantee that we will only process a given integration event once per the respective integration event handler inside of each module. And this is what the inbox pattern allows us to do with the respective idempotent consumer added on top, and I'm going to show you how we will implement this inside of this lesson. So let me give you a step-by-step walkthrough of what I needed to change in order to introduce the inbox pattern. And we are going to start from the infrastructure layer in our common folder. You will see that I added an inbox folder. And if I open up the outbox folder side by side as a comparison, you will be able to spot a pattern between these two folders. So where we had the outbox message for the outbox pattern, we have an inbox message for the inbox pattern. And the structure of this type is the same as the outbox message because we are really just passing messages around and storing them as JSON documents. We also have a respective inbox message configuration where we are setting up the table, the primary key, and configuring this as a JSONB column in the database. We also have the inbox message consumer, where we can track each individual handler for a specific integration event, because we could have more than one handler inside of the same module. And then we have the EF core configuration for the inbox message consumer. We're going to introduce these entities to our database context. So let me show you the user's database context, where you can see that I have a respective call to apply configuration for these entity types. I also added the respective migrations, so now when you start the application, it's going to contain the updated schema in the database with the inbox and outbox tables. We also have the integration event handlers factory, which is almost identical to the domain event handlers factory, with the only difference that it's looking for implementations of the integration event handler interface and returning a collection of integration event handler types which are resolved from a scoped service provider. So as you can see right now, much of this is the same, except it's called an inbox. Now, one thing that is missing from the inbox folder is what could be similar to the interceptor implementation for the outbox that was taking our domain events and persisting them as outbox messages. In the case of integration events, we need something that is going to take in an incoming integration event that is published using mass transit and is going to consume this integration event and store it into the inbox message table. And this is a generic class which I have inside of each module with the name of integration event consumer. You can see that we are implementing the iConsumer interface from mass transit, and we are specifying a generic argument for the integration event. And what we are going to do inside of the consume method is just open up a database connection, take in the message available on the consume context, which is going to be our integration event. And then we're going to convert the integration event into an inbox message. If you recall with the outbox, we were also serializing that into a JSON string. And once we have the inbox message, we're going to write it into the inbox messages table, and I'm going to repeat this for all of my modules. If I open up the ticketing module class and I navigate to the configure consumers method, which is how we configure our mass transit consumers, you will notice that this is now updated to specify the integration event consumer and then the actual integration event that we are handling as the generic argument. So this is going to wire up an integration event consumer for all of the integration events that this module is interested in. I'm also going to repeat this in the other modules in the system. And this takes care of taking in a respective integration event and storing it inside of the inbox messages table. The next thing we need is to actually process this table and handle these messages inside of a respective module, similar to how we were handling our domain events by running each of the handlers one by one. This is handled by the process inbox job, and you can think of it as the brother of the process outbox job. If you take a look at the execute method, it's basically identical. What we have here is deserializing an iIntegration event instead of an iDomain event, creating a service scope, using the integration event handlers factory to get back a collection of integration event handlers. And then we are going to execute the handlers one by one. Another difference with this implementation is that we are going to specify the presentation assembly, which is where the respective integration event handlers are going to live. The process inbox job also has a respective inbox options type, and we are configuring it in the same way by adding an iConfigure options for Quartz options and then adding the job to Quartz as a background service. So this is very much the same like in the outbox pattern. I'm going to close down these types and let's take a look at the presentation layer of the ticketing module. And for example, let's look at the event published integration event handler. This was previously an iConsumer implementation, and now it's an integration event handler for the respective integration event. So when we execute the process inbox job, it's going to resolve this type, among other ones, and call the handle method on this class and specify the respective integration event. Inside of the handle method, I'm going to create a command instance and then send it using Mediator. So this is the same implementation that we had before, only now it's inside of an integration event handler. If I go back to the infrastructure layer for a moment, you can notice that I also have an idempotent integration event handler, and this is the same as the idempotent domain event handler from the previous lesson, only applied to our integration events. So it's going to be a decorator on the iIntegration event handler, which are all implemented in the presentation layer, like this one here, and then it's going to check if we have consumed this inbox message with the specific consumer or the integration event handler. If we did not, it's going to call the handle method and pass in the integration event, and after that it's going to insert the respective inbox consumer into the database. Of course, these are all writing to the respective table in the schema for each of the modules, and you will see a copy of this type for each of our modules. And so far you can see that this very closely matches the implementation for the outbox pattern. If I go back to the ticketing module for a moment and scroll down, you can see a respective add integration event handlers method, which is again scanning the presentation assembly, looking for implementations of the iIntegration event handler interface, registering them as scoped services, and then decorating them with the idempotent integration event handler. So we also have to take care of dependency injection. And in the end, let me show you the integration event handler interface. We have a non-generic version and a generic version, and we also have a default implementation, which is an abstract type that defines the abstract handle method, which we are overriding and implementing in the actual integration event handlers, like this one for the event published integration event. So this pretty much summarizes the implementation of the inbox pattern and the respective idempotent consumer for the inbox. And now I want to show you a complete demonstration of the outbox and inbox patterns in action when it comes to implementing reliable messaging between our modules. I'm going to send a put request to our API to publish a specific message. This is going to raise a domain event inside of the events module that is going to be handled and publish an integration event, and this integration event is picked up by the ticketing and the attendance modules to duplicate the event and ticket type informations. So let's go ahead and send this request. And we are first going to hit the breakpoint inside of the publish event command handler. This is going to publish this event by calling the publish method, and it's also going to raise the respective domain event. So I'm going to press continue, and eventually I'm going to hit the breakpoint inside of the process outbox job for the events module. And you can see that this just happened, and this is going to be handled by an idempotent domain event handler for this specific domain event. And now if I press continue, we're going to land in the event published domain event handler. So we are still in the events module processing our outbox message. Now if you take a look here, this is going to publish an event published integration event. So now we are converting the domain event with a specific ID, which is also our outbox message. So now we can track a given message from an outbox of one module to the inbox of another module, which is an interesting quality that the outbox and inbox pattern enables. So if I hit continue, we are going to publish this integration event using the event bus. And you can see that I immediately hit the breakpoint in the generic integration event consumer. This is going to write an inbox message into the database, and then we have to wait for the process inbox job to pick up this inbox message. And this happened fairly quickly. And you can see that here we have an idempotent integration event handler for the event published integration event. So I'm going to hit continue again, and we land in the handle method of the respective integration event handler, which is going to send a create event command inside of the ticketing module that's going to duplicate the required data for the event and the respective ticket types that are needed for the ticketing module to work. And if I hit continue, you can see that our command has completed. The success status of the result is set to true, so everything went well. And we can also see statements from EF Core in the output window of inserting data into the ticketing events table and the ticketing ticket types table, and saying that we have completed the create event command. If we take a look at the state in the database, this is our event inside of the events module that we just published. The primary key of this event starts with a 4 in the GUID. We also have the respective ticket types for this event. I just have one ticket as an example. And now if I take a look at the attendance module and open up the events table, you can see that we have the same event duplicated, which also means that we have consumed the integration event in the attendance module as well, while in the example I only demonstrated how we were consuming it from the ticketing module. If I open up the events table in the ticketing module, you can see the same message here, as well as the ticket types for this particular event ID that is now also available to the ticketing module. And with this, I'm going to wrap up the story of the inbox pattern, as well as the chapter about reliable messaging. In the next chapter, we are going to talk about event-driven architecture that we are already implementing with the domain events and integration events, but I want to highlight a few patterns from event-driven architecture that I think could be useful, and I want to introduce a new one that we aren't implementing yet, which is the Saga pattern that's going to allow us to implement a distributed transaction.